Hello everyone, this is Prashanth. Let's continue with the last lecture. In last lecture, just I have completed revision on IoT, IoT levels and deployment models in IoT. So IoT levels, just according to our syllabus, we have six types of levels. Level 1, level 2, level 3, having a single node to distribute the cloud among all the devices, or to store the devices and the particular by using WebSocket and web or REST based WebSockets. So and 4, 5, 6, just it uses multiple nodes to collect the data. Like that, we completed the revision on the IoT levels from 1 to 6 levels. Along with domain specifics of IoT, nothing but like home, cities, environment, prognostics, like that. We have 9 types of domains. Under every domain we have different applications, like for example, one of the domain is home. So in the home automation system, intrusion detection system, like that, we have different applications on each and every domain. So these are the things I discussed in the last class. So now we move entering into the logical revision on logical design of IoT. So here the logical design of IoT, including here we have 3 kinds of communication blocks here. The logical design of IoT, it refers to an abstract representation of the entities and process without going into the low level specifics of the implementation. So that is the main aim of logical design of IoT. So generally the IoT levels are IoT specifications are under the physical design of IoT, physical design of IoT. Then we two types of logical design. So here physical design and logical design of IoT. In the terms of physical design of IoT, here we have how the sensors will act as to regarding the data, how the network will build through the IoT devices. Like that, we are going to discuss in the physical design of IoT. Next, logical design of IoT. So these are the things we just it is refers to an abstract representation of the entities and process without going into the low level specifics of the implementation. So basically, it having IoT functional blocks, IoT communication models, and IoT communication APIs. So it is very important. Just revision on under the logical design of IoT functional blocks. So what are the main IoT device having the different peripherals to processing the data? IoT communication model. So we have different types of communication models, like let's see on next slide. IoT communication APIs also, we have 2 types of communication APIs, very important. One is the REST based communication API and WebSocket communication API. So these are the minimum introduction points of logical design of IoT. So here the first functional blocks. So what are the main functional blocks of the logical design of IoT under functional block? It provides the capabilities of capabilities for identification, sensing, actuation, communication, and management. So here identification is nothing but just authorization. Before connect, it can verify the details of the device, then it is going to connect. So sensing, actuation, communication, and management. Device. So here it is the functional blocks of IoT device based on the application. So service, communication, devices. It can provide some security protocols also, how the management how the systems are managed by the particular protocol. So here device. IoT device comprises of devices that provide sensing, actuation, monitoring, and control functions. So this is the main functions of or specifications of device. And communication. So it handles the communication for IoT system by using various communication protocols like Bluetooth, Zigbee, Wi-Fi, whatever the communication protocol is available, depends on our application, just we may use. So that is the communication handles the IoT system to process the data from one device to another device. So next, service management, security and application. Service for monitoring, device control services, data publishing service, and services for device discovery. So this is the about service and management. So here it provides various manage functions to govern the IoT system. Different types of activities or different types of management skills also, management specifications also, it will provide how to manage the system, to gathering the data, to process the data, to analyze the data, to store the data. All things are just it can manage by the management system. And security, it can provide some security protocols also. Here secure IoT system, proximity functions such as authentication, authorization, message, context integrity and data security. So this is about the security. And application, so under the application, it provide an interface that the users can use the control and monitor various aspects of the IoT system. So this is the IoT main functional blocks of the IoT device. So different functions like application management to service, security, device communication, like that. So next, this is the mapping of essential functional blocks of IoT. Just overview of the functional blocks. So under the applications, we have different applications like IoT business process management, that is the SRE, business process modeling and business processing execution. So first, just we can choose the modeling. Then we are going to for the execution, that is the under IoT business process management. And virtual entity. So just in virtual entity service, virtual entity resolution, virtual entity and IoT service monitoring. So this is the virtual entity under and IoT service. So IoT service provides, it is resolution IoT test to services. This is the IoT service. The communication. So in order to develop the communication, just we use gateways, routing and addressing protocols, error detection or correction system like Hamming and Hanning code, like that, energy optimization system, quality of service, flow control and reliability. So these are the comes under communication part. So management. So before going to the management, configuration, fault tolerance, performance, member and state. So this is the management. Under the security, authorization, key exchange management, trust to reputation, identity management to authentication. So these are the some application part here. This is the under the device. So this is application based on the device. We have different specification. Service organization also, service composition and service orchestration. So these are the different applications just we are going to use with the help of IoT functional blocks under. So these are the different knowledge management to test component to resource emulation, network emulation, like that we have different specifications. So this is the mapping of IoT device to the essential functional blocks of IoT. Next, after IoT functional blocks, just we move on to the IoT communication models. Is very important to know in order to process the or in order to develop the communication among the particular sensor transmitter and receiver. So we have some models. These are the IoT communication models, very important in IoT. One of the important topic also this is one. So IoT communication models, I already told. So in order to develop the communication in between any two associated devices in the IoT, we use request response communication model and publish subscribe communication model, push-pull communication model and exclusive pair communication model. So these are the very important communication models to develop the IoT network. So this is the black diagram of request to response communication model or client server. Request is sent from the client, and for request just we got response. This is the server. So here the communication is going on in between these two only. That's why it is called request response communication model, or client server communication model also is known as request response communication model, in which the client send the request to the server and the server responds to the request. For example, just I want to open www.iare.ac.in for our college website. So I want to open this website. just you can type in URL space www.iare.ac.in. so when you click on the enter button on the keyboard, just immediately the request sent to the server. So the server, it fetches the information from the database, whether the site www.iare.ac.in, whether it is available or not. It can fetches the information from the database, immediately it send the request to the client, that is it's me. So that is the process is going on in request to response communication model. And when the server receives a request, it decides how to respond and fetches the data, retrieves resource representation, prepares the response, and this sends the response to the client. So this is the theoretical points regarding request to response communication model. And client sends a request to the server, a request to this is response. Server receives the request from the client, process the request, looks up, fetch up the data from the database. This is the from the resources, nothing but database. From the information, just again send to the response to the client. So this is the process. And just this is the main some elaboration of request to response communication model here. The client, when required requesting the information from the server, the request is usually encoded format. So that is the some elaboration of first slide. So this model is stateless, since the data between the request is not retained. Each request is independently handled. So that is the second one. And the server categorize the request and fetches the data from the database. Its resources representation, this data is converted to response and is transformed to the encoded format to the client. The client in turn receives the response. So some with the in the form of some certain format, just it maintains some format to response sent to the server to the client. So that is the we have to know. In other hand, in a request to response communication model, client sends a request to the server and the server responds to the request. When the server receives the request, it decides how to respond, fetches the data, retrieve the resources, and prepare response and send to the client. So just normal thing, just we already discussed in the previous slide. So the first three sentences are important to write for request to response communication model. So this is the one more elaboration diagram of this communication model. So this is the client. This is the client initially request for the to open the any site server. Immediately the server processes the data from the fetches the data from the database, and again it give to the response to prepare response in encoded format. It maintains some format to in order to prevent the unauthorized access. So it is the request response communication model. So the elaboration black diagram of request to response communication model. And the second one, second type of communication model, that is publish subscribe communication model. Here that involves publishers, brokers, and consumers. So here in the first communication model involves only request server and client only. The communication is going on only two variables here. But here in publish subscribe communication model, there is a third person involved, that is the broker. Publishers are the source of the data. Publishers send to the data the topics which are managed by the brokers. Publishers are not the consumer here. Consumer subscribe to the topics which are managed by the broker. So the broker is the essential thing in the this model. And when the broker receives the data from a topic from the publishers, it sends the data to all the subscribed consumers. So that is the process will done in the this model. So this is the publisher sends message to the topics. Message published to topic 1, topic 2. Under topic 1, consumer 1, consumer 2. Under topic 2, consumer 3. So here consumer 1, consumer 2, consumer 3. So the data will pass through the broker only. So this is the intermediate person in between publishers and consumers in this type of communication model. So this is the normal block diagram of publish subscribe communication model. Just we are going to elaborate this one more, just elaborated points here. The publishers are the source of data. It sends the topic to the particular topic which are managed by the broker. They are not aware of the consumers. And consumers subscribe to the topics which are managed by the broker only. Hence, the broker responsibility is to accept to data from the publisher and send it to the appropriate consumer. So that is the main function of broker here. Just it accept data from the publishers and send the request to the appropriate consumers. And the broker only has the information regarding the consumer or to which a particular topic belongs to which the publisher is unaware of. So this is the just elaboration black diagram of just extension of or one type of diagram here. Publishers, broker, particular sent to the consumer. The information passed to the particular consumer. So this is the topics which are sent from the publisher to the broker. Subscribers are consumer or customers. This is the publisher subscribe communication model. And the third one, push pull communication model here. The third one just it is push pull. The name itself push the data and pull up the data. Here the communication model in which the data procedures push the data to the queues and the consumer pull up the data from the queues. Producers do not need to aware of the consumer. So the data in terms of queues, that is pull up and pull down at the transmitter and receiver. The queues also act as a buffer which helps in situations when there is a mismatch between the rate at which the producers push the data, the rate at which the consumers pull data. Queues help in decoupling the message between the producers and consumers. So this is the black diagram of push pull communication model. Publisher sends the message to the queues and queues. These are the message pushed to the queues and pull from the queues. So it's the consumer one and consumer two. So there is the in place of broker as we discussed in the publish subscribe communication model. Just we have here the queues message pushed to the queues and message pulled from the queues. You can just extract from the information or forward information from the publisher. So the type of situations done in the push pull communication model. So this is just elaboration of the points here. Publishers and consumers are the not aware of each other here. So there is no information where the information is from here. They don't know nothing, consumer and the publishers also responds. They don't know whether it is from where it is coming. So here the publishers publish the message data and push into the queue. The consumer present on the other side pull up the data from the queue. So thus the queue act as the buffer for the message when the difference occurs in the rate of push pull data side of the publisher and consumers. Queues help in decoupling the message between the producer and consumer. Queues also act as buffer which helps in situation where there is a mismatch between the rate at which the producer push the data and consumer pull up the data. So this is the some elaboration points regarding the push pull communication model. This is the third type of communication model is very important to know. The queues, the messages, the input push to the queues and at the output the information extract from the queues only. So the type of activities will be done in the push pull communication model. So here this is the just elaboration diagram. Publishers, it is the message with the help of the queues is black diagram just denotes queues. Message pushed to from the message pushed to the queue and the message pulled from the queues only. So here these are the consumers. So message buffered in the queues one by one according to the time slot or just to maintain one format one by one or at a time all depends on the application. So here this is the elaboration points of the push pull communication model. And the last one revision on under the revision on logical design of IoT. Here we have black exclusive pair communication model is very important. The last one, exclusive pair communication model is a bidirectional push-pull communication model that uses a persistent connection between the client and the server. So here it maintains two properties here, bidirectional and fully duplex fully duplex communication model. So once the connection is set up, it remains open until the client sends a request to close the connection. That is the second one, and the client server send message to the each other after the connection is set up. So these are the some theoretical points of exclusive pair communication model. It maintains two properties mainly, full duplex and bidirectional communication model. So here the client and server first request to set up the connection, just the it is the request, and the response to accept the request. That is the first part, and message from the client to the server, and message from server to the client, the second one, and the closing connection close request and connection close response. So these are the communication is going on in between client and server with the help of bidirectional and full duplex communication in exclusive pair communication model. So just to elaborate of these points here, exclusive pair is the bidirectional model including full duplex communication among other client and server. So the connection is constant and remains open till the client send the request to the close the connection. So it is just waiting in here. Here the connection is constant and remains open till the client sends a request to the close the request. So here first request to set up the connection. So this is the continue up to the connection closed response. So this is the continuous way up to the close the connection close response. Here the server has to record all the connections which has been open. So that is the second one, and connection is a stateful connection. This is a stateful connection model, and the server is aware of all the open connections, and WebSocket communication API is fully based on this model. So this is the client and server request to respond, accepting message, accept message, connection, close connection. So it is just fully full duplex and bidirectional communication way, that is full. This is the elaboration black diagram of exclusive pair communication model. Next, after communication model, just we go for communication API. So here very important term, that is API, application peripheral application programming interface. Very important term. So here we have communication APIs are REST based communication API and WebSocket based communication API. So it is nothing but representational. REST stands for representational state transfer. REST stands for representational state transfer. That is one of the communication API, and remaining WebSocket based communication API. Let's start with before that. First, we need to know about the what is API, what is the specifications of API like. So the API is an abbreviation of application programming interface. Here is a set of routines, protocols, and tools for building software applications. So here some important features are the API specific, how software components should interact, and the API should be used when programming graphical user interface components. And the good API makes it easier to develop a program by providing all the building blocks. And REST, which is typically runs over the HTTP, is often used in mobile applications, social websites, mashup tools, and automated business process. Flexibility is provided by assigning resources their unique universal resource identifier URS. So this is about the some important features of API, application programming interface. It is a set of routines, protocols, and tools for building software applications like. And the first one, representational state transfer. Here representational state transfer is a set of is a set of architectural principles by which you can design web services and web APIs. The focus on the system resources and how resources states are addressed and transferred. So this is the introduction point of representation state transfer. Just I already told. So the REST API REST API follows the request response communication model features. So that's why before going to API in any time, first we have to know the communication models. So the features of communication models will follow the communication API. So here the REST-based communication API will follow the features of request response communication model. So the REST architectural constraints apply to the components, connections, and elements with a distributed hypermedia system. So that is the important point. So HTTP client, HTTP packet, HTTP server, and resources. So here this is the basic block diagram of REST-based communication API. So here REST aware of HTTP client, HTTP command. We have different types of HTTP commands like put to, get to, post to, delete to, like that. So here payload under JSON and XML in the form of response. HTTP server for authentication and RESTful web services. Resources like representation resources, that is URI. So this is the main block diagram of representational state transfer. And these are the some constraints of REST architectural. So here client server, stateless, cacheable, layered system, uniform interface, and code on demand. So what are the meaning of that particular constraints? The client server. The principle behind client server constraints in the separation of concern. Separation allows client and server to be independently developed and updated. So that is the client server. Stateless. Each request from client to server must contain all the information necessary to understand the request and cannot take advantage of any stored context on the server. So that is the stateless. And cacheable. The cache constraints require that data within the response to a request be implicitly and explicitly labeled as cacheable or non-cacheable information. If a response is cacheable, then the client cache is given the right to request the response data for later equivalent request. And layered system. The layered system defines its constant behavior of the components, such as each component cannot see beyond the immediate layer which they are interacting. And uniform interface. It maintains the request that the method of communication between the client and the server. The last one, code on demand. The services can provide executable code on code or scripts for a client to the execute in their take context. This constants is the only one that is optional. So this is the these are the some representational state transfer constraints. Client server model, stateless, cacheable, layered system, uniform interface, and code on demand. And advantage and disadvantage of REST API here. Under the advantage of API, it maintains simplicity of the connection, flexibility, caching, and stateless. Caching and stateless, these two are already discussed in the API constraints here. Simplicity is nothing but it is relatively simple to design and implement, making them a popular choice for building APIs for web applications. So here, in order to build web applications, very important term you have to remember. Web application, just we use very simple design and development implementation of the REST API. And flexibility. So here REST API can be used to support a wide range of applications and services, from simple web application to complex enterprise systems. That is the second one. And caching and stateless here. REST API can leverage caching to improve performance and reduce server load. Stateless. REST APIs are stateless, meaning that each request is processed independently of any previous request, making them easy to scale and distribute. So these are the advantages of REST API. Next, coming to the disadvantages of REST API. Limited real-time support, performance overhead, and complexity. What is limited real-time support? In order to design real-time projects, the advantage of REST API is very limited. So in terms of it does not support for real-time communication between server and cloud, making them less suitable for applications is require real-time updates. So that's why we are not using REST API for developing of the some of the API project, IoT project. So just we go for always WebSocket communication API that comes in next slide. Performance overhead. The REST APIs require more overhead than WebSocket API, as the request and response must contain all the information to complete the request. Complexity. REST API can be complex to design and implement for large distributed systems. So these are the disadvantages of REST API. And the last one, communication WebSocket communication API. So it is very important in order to develop the real-time IoT projects. Real-time IoT projects, WebSocket communication APIs to just it uses WebSocket communication API. It is allows bidirectional full duplex communication between the client and server. So we already know, I already told many times. So it is the before communication REST API, it follows the features of request to response communication model. But here WebSocket communication API, it follows the exclusive pair communication model, features of exclusive pair communication model. So that's why it is bidirectional and full duplex communication between the client and the server. So this is the important introduction points regarding WebSocket communication API. So client and server, just same setup WebSocket connection, request accepting, data frames. These are connection close requests. So here just the black diagram, just we explain in terms of three terms. Initial handshake, that is over HTTP protocol, and bidirectional communication over the persistent WebSocket connection. The next one, the last one, closing connection, closing request and closing accepting. So here this is the main some revision points on the WebSocket communication API. So here advantage of WebSocket API and disadvantage of WebSocket API here. Real-time communication efficiency, scalability, reduced overhead of the these are the advantages of WebSocket API. Real-time WebSocket API enables the real-time communication between the server and the client, making them ideal for applications that require real-time application. So in previous REST-based API here, it is not suitable for developing real-time application in between the client and server. That is one of the advantage. But here disadvantage. So here it is support for real-time communication. So it is the advantage of WebSocket API. Next, efficiency. WebSocket API are more efficient than REST API for real-time applications, such as the persistent connection to enable bidirectional communication. So that is the efficiency. And scalability. WebSocket API are highly scalable, as they can support thousands of connections per user. So that is the scalability. And reduced overhead. WebSocket API can have lower overhead than REST API, as they use a single connection to transmit the data from the client to the server. So this is the one of the advantages of WebSocket real-time communication: efficiency, scalability, reduced overhead. And disadvantages of WebSocket API. So here complexity, security, and compatibility. WebSocket API are more complex to design, implement than REST API, requiring additional programming skills and knowledge. So this is the complexity, but it will give better output at the time of output. And security. WebSocket APIs can vulnerable to security threats if not properly secured. Compulsory, just we want to design in any network, compulsory security protocols also we design very proper manner. So there is no need of bother about the security. And compatibility. WebSocket APIs are not supported by the all browsers, requiring fallback mechanism for older browsers only. So this is the disadvantage of WebSocket API. Similarity between the REST API and WebSocket here. Both REST API and WebSocket API are used to build for web application. That is the API and WebSocket are standardized interface that enable communication between the server and cloud. Similarities. It is the both API are customized to suit specific needs for a particular application or system. So this is the one of the similarity. The last similarity here, it is secured using various authentication encryption methods. So these are some similarities between the REST API and WebSocket API. So next, the main differences between the REST API and WebSocket API here. In terms of different protocols, like stateless protocol will not store the any type of data. It will store the data unidirectional, either client and server will communicate. Here bidirectional and full duplex it maintain, and request response, it follows the request response communication model. It is for full duplex model or exclusive pair communication model. Exclusive pair communication model. And HTTP request contains like some HTTP commands get put like delete like that. It is suitable for real-time application. It does not have any overhead. It is not support for real-time applications. New TCP connection will be set up each HTTP request. So it is this maintain only a single TCP connection. So here we can add both horizontal and vertical scaling, but here only vertical scaling are applicable for WebSocket API. It depends on the HTTP methods to retrieve data, depends on the IP address and port number to retrieve the data. So here it is slower than WebSocket regarding the transmission of the message. WebSocket transmits message very fastly than REST API. It does not need any buffer to store the data. It requires memory and buffers to store the data. So these are the comparison differences between the REST API and WebSocket API. So here in summary, we already know just serve the different purposes and used in different context, we know. And REST API used for stateless request response communication over the it is bidirectional communication model, we know. Understanding of differences between REST API and WebSocket API is essential for choosing the right API for your web application and achieving optimal performance and user experience. So these are the some summary points or conclusion points regarding REST API and WebSocket API. So these are the some references I used for this lecture. So this is the revision on logical design of IoT. So here the logical design of IoT including IoT functional blocks, IoT communication models, IoT communication API. So it is very, very important, these three under logical design of IoT. When at a time when you go for API, compulsory you have to know the knowledge of communication models. So the same features will be applied on the communication APIs also. So remaining continue with the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.